Hi, my name is Sung. I'm your online maths mentor, and we're looking at permutations and combinations, or the chapter to do with counting principles using permutations and combinations, yeah? And we've been looking specifically at permutations, which we understood as being an arrangement of different objects or different elements, where the order in the way that we arrange them will matter. Okay, where the order doesn't matter so much, we are then looking at a different concept, and that is combinations. But here we're looking at permutations. And we also realized that there is a general formula or a general approach to finding the number of arrangements, and that is using the notation NPRP for permutations, N being the number of permutations that you are selecting from, or the number of elements that you are selecting from, or the total number of elements in the whole group that you're selecting from, and R is the number of elements that you are selecting into, right? So you've got NPR, and that is given by the formula N factorial over N minus R, right, in brackets, and that should be in brackets, factorial, okay? And what we realized is that while that is the general formula, there are some common variations that we need to consider that, that actually make using this formula not as simple as we might first think. We might have to modify the way we use that formula. And some of the common variations include restrictions, which we looked at. In the last episode, I think we looked at groups within groups, right? And the variations of using this formula for groups within groups, right? Or where you have a group where you've got subgroups involved. And now what I want to look at is identical elements. Now, identical elements really, there's some, I guess there are certain questions that you get, but a really common type of question is the one that I've got over here, right? Which basically outlines what identical elements are and how it actually causes a little bit of havoc when doing permutation type questions. And here we've got the question where it says this: how many 6-letter word arrangements can be created from the letters of the word mammal, right? So see how you've got 6 letters? Even though you've got 6 letters, you've really only got 3 distinct letters, yeah? Because you've got the 3 M's, which are all identical. They're your identical elements. You've got the 2 A's, which are identical to each other, and you've got the L. So your 3 distinct letters are M, A, and L, but you've got 6 letters that you've got to arrange, yeah? So how do you do a question like that? Okay, well, let's go to our starting point, and that is, our starting point is this, right? Our starting point is to recognize that where you've got 6 distinct letters, right? Not that these are distinct yet, right? But where you've got 6 distinct letters, the number of arrangements that you have is 6p6, or another way of saying that is 6 factorial. Got it? So 6p6, right, is the number of distinct arrangements that you have, and that's because you've got 6 positions, 1, 2, 3, 4, 5, 6, and each of those 6 positions get filled up accordingly. So in the first position, you would have 6 distinct elements, so you've got 6 choices that you can put into the first position. The second position, you've got 5, because there's 1 less than the one that you've anchored into this position. You've got 4 for this one, 3 for this one, 2 choices, and then 1 choice. So here, do you see that you've got 6 factorial choices, or sorry, 6 factorial arrangements of the word, of a 6-letter word where all the letters are distinct? Got it? All right? Put that in your calculator. Punch those numbers in, see what it spits out. It should spit out 720, okay? So that's basically 6 factorial, right, arrangements. Good. What I want you to notice is that this is for 6 distinct letters. We are going to take the letters of the word mammal, and we're going to make them make each letter distinct. So we're going to make this M distinct from this M. which is distinct from this M as well. So let's do that. Let's take, for example, M1, let's call it M1, A1, M2, M3, A2, and L. Okay, there's only one L, so we don't have to put a number next to the L. But let's say, right, we've got, instead of having M1, M2, and M3, sorry, in other words, rather than having M, M, and M, let's make it M1, M2, and M3, okay? And the reason why I do that is simply to demonstrate this. See how you've got M1, M2, and M3? That, we're going to consider these three M's as one distinct sub-arrangement, or so one distinct internal group within the whole, okay? So, where that's the case, positions 1, 3, and 4, positions 1, 3, and 4 are going to be filled up with your 3 M's, right? Now, it can be M1, M2, M3, and you would still have the word mammal. It could be M1, M3, M2, and you would still have the word mammal. It could be M2, M1, M3, M2, M3, M1, could be M3, M1, M2, M3, M2, and M1, right? So you've got 1, 2, 3, 4, 5, 6. You've got 6 sub-arrangements of 3 distinct M's in the word mammal that's arranged this way. Does that make sense? Now, what I want you to see is that even though you might have 1, 2, 3, 4, 5, 6 ways of sub-arranging all the M's in positions 1, 3, and 4, they're still the same word mammal if M1, M2, and M3 were identical, right? So what you've got to do is take these 6 and divide 720 by 6. How did we get 6? Well, 6 is really just the number of ways that you can arrange 3 elements into 3 different positions, right? So basically what you've got is the total number of arrangements if you had 6 distinct elements, which is 6 factorial, divided by 3 factorial, which is the number of internal arrangements for these 3 distinct M's, which will all, if they were distinct, would all be collapsed down into one arrangement if they were all identical. And then you'd also divide by 2 factorial, because you can either have A1 and A2 or A2 and A1. They're your 2 arrangements of A, which will just be identical if you didn't have to make the distinction between A1 and A2. All right? So really what you've got is 720, or 6 factorial, which is 720, which is all the arrangements if you've got 6 distinct letters, divided by all the internal arrangements of the 3 identical M's, divided by the 2 distinct arrangements of your 2 identical A's that will fit in along the big, all the arrangements of the 6 letters, the bigger 6-letter word. Okay, so what you've got is 6 factorial divided by 3 factorial divided by 2 factorial, and that ends up being 720 over 6 times 2, which will give you, what's that, 60. Okay, so that is your answer for the number of arrangements of the word mammal where your M's are identical and your A's are identical. Okay, now I may have gone through that a little bit quickly, all right, and you may not have got it the first time, but go back and watch the episode again. Go away also and practice some questions that have to do or that do involve identical elements, and with practice it'll get clearer. Okay, so thank you very much for watching. I'll see you on the next episode, which will be the last variation of permutations, and then we'll move on to combinations. Thank you very much for watching. Bye.